Let me know where your problem is. Now we are about linear transformation. How are you viewing this voice, guys, and the video also? Let me check how it appears. Before starting this class, guys, I do want you to subscribe on the channel. And the help I want from you is to share the live. Make sure you share the live. Make sure you subscribed. Okay? Make sure you share the live. I do want to open my channel. Okay, there are 2 likes. I thank you for your great help, guys. Okay, let's hope everything now is clear. Let's hope everything here is clear. Now, it's my time to start the live. How are you seeing the video? How are you seeing the video, guys? Is the video good? Does it look good? Oh, it does not. Is it looking good? Is the video horizontal or vertical? Let me hope it's vertical. It's horizontal, sorry, not vertical. I'm trying to switch on the channel to see what you are watching. Now, here is about linear transformation. Our previous lesson was about showing whether any transformation is linear, and as if I remember, I left you some exercises to prove whether a transformation is linear. Okay. And the transformation to be linear, as you saw it yesterday on our previous course, it must satisfy the following two properties. If fxy is linear, if this is linear, the properties must be had. F of u plus v must be equal to f of u plus f of v. Here, both u and v are vectors. Another property for alpha a real number, f of alpha u must be equal to alpha times f of u. Okay, now there is another formula that groups these two formulas together. What is it? The formula that groups these two together is generally for alpha, beta, real numbers, f of alpha u plus beta v must be equal to alpha times f of u plus beta times f of v. Let me hope that you remember those two properties that verifies whether a transformation is linear. Can I have one simple example in order to continue with the lesson? If I can, I'm waiting you to tell me. And the group has no message, but hope you are really watching. Now, let's have one simple example. The example we gave you in our previous lesson was if f of xy is equal to x plus y, comma, then let me have 2x plus y. If f of xy is x plus y, comma, 2x plus y, verify whether or not fxy is linear. As I told you, this f to be linear, we must be having u, vector u, and vector v. Now let's answer the question. We can use this formula or these two formulas. Now for us, let's prove this. If f of alpha x, alpha u, sorry, plus beta v is equal to alpha f of u plus beta f of v, this implies that the function fxy is linear. Now, let's do how to show this. As I told you in our previous lesson, we assume you to be x1, y1. This means alpha u is gonna be alpha x1, comma, alpha y1. let V be this x2, y2. This means beta V is gonna be beta V1, beta x2, sorry, comma, beta y2. Here it's. Let's continue. Here we need to have alpha u plus beta v. What is this? This is gonna be alpha x1 comma alpha y1 plus beta x2 plus comma beta y2. This is gonna be, as you see, you know how to add two vectors. This alpha x1 will be added to beta x2. That's why you're gonna have alpha x1 plus beta x2, comma this and this, alpha y1 plus beta y2. As you see, before continuing, what we are going to see is that this will stand for x and all of this stand for y. Okay, so in our transformation, which is this, x is going to be replaced by alpha x1 plus beta x2, and y is going to be replaced by alpha y1 plus beta y2. Okay, now we have f of alpha u plus beta v. This is going to be f of alpha x1 plus beta x2, comma, alpha x2 plus beta, here is y1 alpha y1 plus beta y2. As you saw, this is going to replace x and this to replace y in the given transformation. This is, we have x plus y. Instead of writing x, we are going to write this stuff. Here is alpha x1 plus beta x2 plus, here is y. Y is going to be replaced by this. Here is alpha y1 plus beta y2. And here is a comma. This is a comma. That's why this is going to be 2 into 2 times x. And remember, x is replaced by alpha x1 plus beta x2 plus y. And y is replaced by alpha y1 plus beta y2. Now here it is. What am I now going to do? You see x with sub 1 and y with sub 1. These are going to be grouped together. And x sub 2, y sub 2 will be grouped together. This is going to be, this is alpha x1 plus alpha y1. Let me have it like this, plus those with x2. Here is beta x2 plus beta y2. Comma, do the same here. This is going to be 2 alpha x1 plus stuff with sub 1 alpha y1 plus 2 beta x2 plus beta y2, as you see here is. So I'm going to have this, comma, this. You see, I'm going to have this here is comma this. The first one, comma the first one. Plus the second one, comma the second one. Okay, this is gonna be alpha x1 plus alpha y1, comma 2 alpha x1 plus alpha y1, like this, plus this and this. This is gonna be beta x2 plus beta y2, comma 2 beta x2 plus beta y2. Now, the first stuff consists of alpha everywhere on each element. That is why this alpha is going to be taken out of this parenthesis. Here is alpha into x1 plus y1, comma 2x1 plus y1, plus do the same for this where beta is everywhere. Take out beta. This is going to be x2 plus y2, comma 2 x2 plus y2. As you can see, this is a function of u because our u is x1, y1. And as you see, this is x1, y1, x1, y1. This is a function of u. And this is going to be a function of v. So for this, f of alpha u plus beta v will be alpha times f of u plus beta times f of v. Since this property, the left has the right like this, we conclude saying, conclusion, f of xy, which is equal to x plus y, comma 2x plus y. This is linear. In other words, the transformation is linear. If you have any problem, guys, you can let me know. I hope. Isn't that clear? Niyonzima Alphonse, isn't that clear? Please let me know if you can see it. Arisia murakorera kuri iyi link, yego. Murakoresha iyi link, salamuka, yego, salamuka. You can join the lesson, salamuka. That is, it doesn't matter. Okay. Let me share this link to someone in Uganda to see if he's going to join us. Okay. Let me now give you my link. Okay, thank you very much. Now we are going to continue our class by what? We are going to continue the class just by learning how to find the inverse of a linear transformation. Hope now you are watching that carefully and the writings are very clear. Let's now continue with how to find the inverse of any linear transformation. How do they calculate the inverse of a linear transformation? Hmm. Let me hope you will share this lesson with your friends, guys. Let me hope you will share the class with your friends. We continue with inverse of a linear transformation in 2D. After finding this, or before going to the way of finding the inverse of your linear transformation, I would like to remember you how to find the determinant of any matrix. Here, because we are dealing with 2D, we are going to see or to remember how do we find an inverse of a 2 by 2 matrix. Remember this. Recall. If a matrix A is A11, A12, A21, A22, how do they find the inverse of this matrix? As you remember, before finding the inverse, we first of all find the determinant of this matrix, where we take a product of main diagonal elements. Here we take this, the product of this. Here is A11, A22 minus the product of this. Here is A12 times A21. This is how we get a 2 by 2 matrix determinant. Now, the inverse of this matrix is given by a reciprocal of the determinant of matrix A times the adjoint. The adjoint here is got by switching the leading diagonals. We switch them. One, or let's say we interchange the leading diagonal elements. Where here we start by A2, 2, and here A1, 1. And what's next is to multiply the second diagonal elements by 1. Here is going to be minus A1, 2, and here minus A2, 1. This is a 2 by 2 inverse matrix. Is this way same as the other you taught us yesterday? Yes, here it is. And I'll come back with the second way. Now, let's go with matrix or linear transformation. Let this f of xy be a11x plus a12y, comma, a21x plus a22y. If I have a transformation like this, what I do, this is the same as having, we need to let this transformation in matrix form, so that here will be x and y. Here is going to be xy. Now, what's next is to consider only the coefficients, where these coefficients will be the 1. Here is a11, a12, and here a21, here a22. Now, we assume this to be a times xy. What we need, the inverse of linear transformation xy will be looking the same as the inverse of matrix A. You see, we transform or we find the inverse of this matrix, but times xy, and multiplication continues that way. Now, I'm going to continue with examples of the second way. Okay. Okay, I'm going to give you guys another way of finding the inverse of a linear transformation. I say any linear transformation. Okay, now before continuing, let's have an example, and we'll be working that example using the second alternative. Let's have this linear transformation xy, which is x minus 2y, comma, x 3x plus y. This example. This one. If the transformation is this, find the inverse transformation of x and y. Okay? Now, as I told you, answer, I can let this transformation in matrix form, where f of xy will be, as I told you, because here you have xy, we need to let here xy, and we are going only to let the coefficients of x and y. The coefficient of x here is 1, while the coefficient of y here is -2. The next, the coefficient of x here is 3, while the coefficient of y here is 1. We need to assume this as a matrix A. If that is a matrix A, the determinant of that matrix will be given by this times this, that is 1, minus this times this, which is -6. Here is going to be 1 plus 6, and this is 7. We saw that the inverse of matrix A is got by switching the leading diagonal elements where all are the same. We multiply, and the second diagonal elements are multiplied by -1. That's why -1 times -2, that is 2, and -1 times 3, that is 3. But we have a reciprocal of the determinant where matrix determinant is 1/7. That's it. So the inverse transformation will be given by, we take this 1/7 and multiply to the matrix. Here is 1/7, and here is 2/7. Here is 3/7. Is it only 3 or -3? Because here this change the sign. Here is -3/7, and here is 1/7. Then we multiply x and y. This is, you know how to multiply matrix and a vector. We take the row and dot it the column. So here 1/7 times x was x. This is 1/7 times x plus this times this. This is 2/7 times y. Come on. We go to this. -3/7 times x, that is -3/7 x. 1/7 times y, that is plus 1/7 y. So the inverse of this transformation is this. Can you see the second alternative, guys? The second alternative. The second alternative Alternative 2. We assume f of xy to be, we assume it to be u and v. We let f of xy be u times v. That's it. This means x minus 2y, 3x plus y. This must be uv. This is where x minus 2y equals u, and 3x plus y, this equals v. After this, I swap. After this, what I want is to swap x, y, and uv. This means instead of having x, we'll have u, and here x will be replaced by u. That's, here is u minus 2, and y is going to be replaced by v. And this is because we swap x and y to be uv. Here, instead of having u, we're going to have x. Even here, we have 3u plus v, and this is gonna be y. What I'm going to do is to eliminate all, solve for u and v. That's what I'm now going to do. I'm gonna solve for u and v. Let me eliminate v because here is minus 2. I multiply to the second equation. This is gonna be u minus 2v, which is x, and here multiply the second equation by 2. We have 6u plus 2v, which is 2y. Now summing these two equations, I'm going to have this. We simplify this or vanish it. That's why here we have 7u. We have 7u, which is x plus 2y. And as you see, here u is gonna be 1 over 7 times x plus 2 over 7 times y. That is u value. We can have v. We can replace that u here or eliminate u to find v. Let me go back to u minus 2v, which is x, and 3u plus v, which is y. If I'm going to eliminate u, I need to multiply the first equation by minus 3. Because here is 3, here must be minus, in order for the equation eliminates u to stay with v's. This is going to be minus 3 times u, this is minus 3u, minus 3 times minus 2, that is plus 6v, and this is going to be minus 3, guys. Okay, now here we have 3u plus v, which is, here is minus 3x, and this is going to be y. So eliminating this will vanish. Another means 3 minus 3u and 3u will be equal to 0. Now I'm going to sum this and this. Here 6v plus v, that is 7v, and this is going to be minus 3x plus y. That is clear that v is going to be, we divide the variable by 7. This is going to be minus 3 over 7x plus 1 over 7y. In other words, because we now have the value of u, the value of v, the inverse function will be given by u. E has this value. This is 1 over 7x plus 2 over 7y, comma, our v is minus 3 over 7x plus 1 over 7y. As you see, the inverses are the same, guys. There any problem? Any problem with the example? Please let me know if you have. Otherwise, I'll be continuing with the question and the lesson. By now, I do want to give you some examples, at least 2 examples, in order for me to know if you are well hearing the lesson or the lesson is well understood for you. If you have any question, please guys leave it in comment section. There is one example and we need to deal with other examples, at least 2 or 3, and those will be your exercise. Okay, let me delete this. If you get one point that seems to be challenging for you, please let me know it in comment section. That comment section is yours to announce me what is looking challenging for you guys. Okay, now we're gonna have examples. Someone Arbril alavuga ngo assalamu alaikum wa alaikum salam wa rahmatullah wa barakat. Hope you are going and being good. Wa alaikum salam dear. Wa rahmatullah wa barakat. Now let's continue with exercises. So whether the following transformations are linear or not. Here we have 5 questions. Okay, let me look for others. Question 1. If f not here is not about showing whether a transformation is linear, not on that, and find their inverses, their inverse transformations. One, we have f xy, which is x plus 2y, comma, x minus y. The second one will be about, let me have t xy, which is y, comma, to x. 3 is about g x and y, It's gonna be x plus y, comma, x minus y. For we have hxy, which is 3x plus y, comma, 3x. 5, let me have fxy, which is equal to minus 2x plus 4y, comma, minus 2x minus 7y. Another one, the last one is, let it be txy, and this is gonna be x minus y, comma, x plus 2y. Let me now hope it's very clear. Omniza Teta Jessica, alaikum salam wa rahmatullah wa barakat. Assalamu alaikum wa rahmatullah wa barakat. Omniza Teta Jessica, hari ibyo uri kwandika ntitubibone. Teta Jessica, ibihe teacher, kubera iki izo elements zindi zigiyeho negative? Which ones there? Izihe elements? Bamwita Mudeng Grace. Which element are you meaning? Is it this? Is it what? I don't know what you are trying to say. Please write in comment and specify where the question is. Our next thing we are going to deal with is the composite transformation, guys. It's all about composite transformation. Before continuing, I would like to recall you to share the video, because here you are, a number of 7 of you are watching. Please share the video with your friends. Remember to like the video. Among you, 2 of 7 have liked the video, and others are watching. Do not forget to subscribe. Have you seen that algebra is new here? I don't know whether she's Rwandan or not. I don't know that. But maybe whatever she is or whatever is, we know where that he's or she's our friend. Don't miss our live anymore, dear friend. Akil, Akibril, R7K for N. Okay. Hope that all of you have subscribed to the channel. This channel was dedicated to make mathematics somehow easy. Let me hope it is easy for you also, as it is for me. 5 of you are still watching. Now, let's continue with composite transformation. We are going to deal with composite transformation. I'm so sorry to clean here. I've forgotten what was my aim. My aim was to clean here, and unwittingly I deleted stuff that I listened to like. Okay, but no sample, no sample. Don't have any problem with me. Don't have any problem with me. Okay. Let's now continue with composite transformation. But before continuing, let me check your WhatsApp group. There is nothing new there. Okay. The composite transformation. This also can be done in two different ways, of which one of them will be is gonna be the use of matrix, while the other will be done in the way I'll be showing you. Now, let f, x, y, and g, x, y be two transformations. Their composite transformation in be written. Their composite transformation. Their composite transformation can be written as I can have f or g of xy or g or f of xy. So guys, how is f or g xy found? How g or f xy found? This will be given by the product of the matrix of linear transformations. Since both are 2 by 2 transformations, okay? Step 1, express f of xy in matrix form. Again, express gxy in matrix form. Now, if f of xy can be written as matrix A times xy and gxy a matrix B times xy. The composite transformation f or gxy can be A times B. We have the product of two matrices, then times xy. G or f xy will be the matrix B times the matrix A times the matrix A, but also times x and y. The vector xy. Now, that is how we find composite transformation. But this is the first method. I'll be showing you the second method. And you'll be choosing which one between the two methods is simple and easy to use for you. Okay, let's have an example. Assume, let's have f of x1, let's have these two transformations, the first two. Here, fx is x plus 2y, comma, x minus y, and let me call it gxy as y, comma, 2x. Okay, now we need to find f or g xy and g or f x comma y. I'm going to keep the answers here. Before continuing, guys, I'm gonna check your WhatsApp group. Okay, there is no new message here. Now we can write transformation f in matrix form. As we saw, we like the coefficient of x and y, where this becomes the first law and this the second law. Here the coefficients are 1, 2. The coefficient of x is 1, the coefficient of y is 2. Now the second one, the coefficient is 1 and the coefficient of y is minus 1. Then times xy. Here g xy in matrix form, as you see, the first component has 0x, means the coefficient of x here is 0. Here is 0 and the coefficient of y is 1. Coming here, the coefficient of x is 2, the coefficient of x is 2 and the coefficient of y is 0, then times xy. Here, f or g xy will be given by the product of these two matrices. Here, the matrix for f is the first one. This is 1, 2, 1 minus 1 times 0, 1, 2, 0, and then times xy. This is going to be, what is this, guys? This is going to be 1 times 0, that is 0 plus 4. Okay? Here is going to be 1 times 1, that is 1 plus 0. Remember here we multiply xy. We are here 1 times 0, that is 0. We have 0 minus 1 times 2 minus 2. Letting this times the second law, 1 times 1, that is 1 minus 0. So this is going to be 4, 1 minus 2, 1. And this is here multiply xy. This is going to be 4 times x, 4 times x, that is 4x, plus 1 times y, which is 1, comma, minus 2 times x, this is minus 2x, plus y, comma. Here is f or g xy. This is how it's calculated. Now, let's look for g of xy. You know that the product of two matrices is not commutative. For that, when the product is commutative, the matrices are said to be commuting matrix. I know, hope you know that. Now, this is going to be, what is matrix for G? The matrix for G was this. We have 0, 1, we have 2, 0 times, we have 1 for F, 1, 2, 1 minus 1 times xy. As you see, this is going to be 0 times 1, that is 1, that is 0, 1 plus 1 times 1, that is 1. So we have 0 plus 1, that is 1. 0 times 2, that is 0 plus 1 times minus 1. Here is going to be minus 1. Let's use the second law. The second law is this. We have 2 times 1, that is 2. 0 times 1, that is 0. We have 2 plus 0, and that is 2. Now, the next is, we have 2 times 2, that is 4, plus 0 times minus 1, which is 0. We have 4 plus 0, and here is going to be 4 times xy. So, G of xy is given by, we are going to multiply the matrix and the vector. Here is going to be x minus y, comma, 2x plus 4y. Hope you are getting that. Nothing big, nothing difficult. Here is another comment. Mudengi ati nabibonye teacher. Thank you very much. Okay. As I told you, if you share the video, it will be helpful for me, guys. Not only for me, and even for you. Let's continue with the second alternative. Other alternative. We'll be choosing which one among these two ways Oh, which one between these two way is simple because we need the one that will simplifies. We need the one way that will simplify our work. The one that will simplify our work to save our time. We need our time to be saved, guys. Let me tell you, my friends, I'm happy to host a Muslim on our channel. Was say this way is the same as the last one we saw yesterday. Yes, hope I have answered this. Here, Kevin has sent a picture, so it's not linear. Which one is not linear, dear friend Kevin? I'm getting your point. Okay, I'll be checking that, but that transformation will be linear. I guess it's gonna be linear. But thank you for trying. Okay, thank you very much for trying. I'll be showing you how. Now, let's use the second method, method 2. Recall fxy was, what was it? It was, it was this. It was this. We have taken x plus 2y, comma, is it? Yeah, x minus y, if I remember. Now, the second one was g xy, which was y comma 2 2x. Now, f of g xy, this will be f into g xy. This is going to be f and g. Our gxy was y into x. Here is y to x. Okay, what was this? As you see, here y will replace x in f. Y is going to replace x in f, while 2x will be replacing y in f. So this is gonna be, because f of xy was this, I told you that x will be replaced by y. X will be replaced by y. Instead of having x, we'll be having y. Instead of having y, we'll be having 2x. Here, we are going to have y plus, it's y plus 2 times 2x. 2 into 2x, comma, instead of having x here, we're going to have y. Here is y minus y is replaced by 2x minus 2x. This is the same as having 4x plus y, comma, minus 2x plus y. That is g of x. Look, this is similar to this. And as I told you, you need to choose which method is very easy and simple for you. I do want you to choose any method of your choice, any method of your choice that will make you hear the lesson. Now, let's go for GOF XY. This is gonna be G and f of xy. This is G. What is f of xy? F of xy is x plus 2y, comma, x minus y. Okay, look, this will stand for x in G, and this will stand for y in G. Remember, gxy was y minus 2x. That's why instead of having y, we're gonna have x minus y, because y is gonna be replacing is gonna be replaced by x minus y. So here, instead of writing y, we are going to write x minus y. That's why this is x minus y, comma, here we have 2x, 2, and x is replaced by x plus 2y. X, sorry, here is not 2x, here is x plus 2y, guys. Here, g of xy is gonna be x minus y, and 2 times x, that is 2x, plus 2 times 2y plus 4y. Is this the same as this, guys? Yes, it is. Okay, never stop running. Never. Keep reading and running at the same time. Stop memorizing mathematics, because here is a good channel for you to follow. This channel will be helping you to learn step by step mathematics, where questions are solved showing each way. If you have any question, you can now ask. If you have any question, you can ask to get helped. Okay. Now we can continue with the questions, and hope the lesson is well understood. Can we continue? Can we? As I said, there is no comment, there is no any message which is new in your WhatsApp group. Dear friends, if you want, you can follow us on our email. We have a TikTok account, which is the names Learn Maths Iga Imibare as our YouTube channel. Our TikTok account and the YouTube channel have the same name. They have the same name. You can go there and follow us. Let's continue with exercise, guys, so that we can end this journey quickly. I need to hear from you if my voice is clear. If it's not, you can tell me so that I'll be able to change something. Right, guys. Here, GOF is right. Exercise, guys. For the linear transformation, for linear transformations, F is a mapping that maps R2 to R2 by fxy. Here is x comma 3y, g R2 to R2 by gxy. 3x plus 4. I'm sorry. Here is minus x plus y minus 2x plus 3y. Show that both f and g are linear. Here is A. Find f inverse of xy and g inverse of xy. After this, show whether f inverse xy and g inverse xy are linear. C. Find the composite transformation. The composite transformations. I f o g xy Lehman 2 GOF xy Lehman 3 FOG inverse of xy Lehman 4 GOF inverse xy. Here D is about prove that f xy and f inverse xy are inverse functions. Here is I Lehman 2 prove that g xy and g to the power of minus 1 of x1 are inverse functions. Here is the exercise, guys. Hope you will do this exercise without any delay. So our next subunity is the matrix of linear transformation. the matrix of linear transformation. Hope you know what a linear transformation is, and the matrix of linear transformation relative to standard basis. So what is it? I want to remind you guys, if you have any question, please leave it in comment section so that next time we'll be working on it. Nabonye there is no new. Okay. A matrix of a linear transformation. The matrix of a linear transformation. Let me have like a definition. Evely. Linear transformation. If a linear transformation that maps L2 to L2 can be identified with a square matrix of order 2. This, the matrix of linear transformation relative to the base. The basis E is the matrix A R J, whose j column is f of ej. Here ej is a factor where ej such that j is 1, 2, because we are dealing with a 2 by 2 matrix of linear transformation. Remember, our transformation is of order 2. When it comes to over 3, you'll be using the same procedures. E is the standard basis of R2. And the matrix matrix F relative to the basis E is called the matrix of linear transformation. The matrix representation of F relative to the basis J. Okay. Here are two things I want you to keep in mind. Was occurring, we are not seeing anything. Was the problem solved? Was the problem solved for you? Was it solved, or the problem is still here? Please let me know if it was solved. Okay. Maybe this message for was occurring last round. It's been there. Now, the standard basis of R2. R2 E1, which is 1, 0, and E2, which is 0, 1. So, when having this, we'll be finished with the question. Now, let's have one simple example. Find the matrix representation of F. Matrix of f relative to the standard basis. If f is mapping that maps L2 to L2 such that fxy is gonna be 4 minus 2y, comma 2x plus y. Okay, as I told you, the standard basis of L2 are this. These are standards. They are also called canonical basis of L2. Hope that you have no problem with that. Okay, I'm thanking God for about 2 new subscribers to the channel. Keep sharing the listen, guys. Now, okay, let's go together, my dear friends, with the answer of the matrix. Okay, what we need to do, as it was said here, we find f of ej. That is, we need f of e1 as the standard basis. Standard basis e1 is 1 0 and e2 is 0 1. So we need to find f of e1. This is going to be f of 1 0. 1 will be replacing x while 0 will be replacing y. So this is going to be, here is going to be 1, here 0. That's why in place of x will be take it there 1. We have 4 times 1 minus 2 times 0, comma 2 times 1 plus 0, and this is going to be 4, comma 2. F of E2, guys. F of E2 will be referred as f of 0, 1 because E2 is 0, 1. Remember, we have the standard basis, not any other base. Now, this is going to be 0 will be replacing x and y will be replacing y. So here is going to be 4 times 0 minus 2 times 1, comma 2 times 0 plus 1 plus 1. This will be 0 minus 2, this is minus 2, and comma 1, 0 plus 1, that is 1. So remember, this vector can be written as 4, 2 as a column vector, and this is written as minus 2, 1 as a column matrix. Okay, let's hope there is clear. Till here, there's no problem of finding the matrix representation of f relative to the standard basis or the canonical basis. But the problem is, how do we find The matrix of linear transformation relative to any other base. There is the problem, and that problem must be well addressed. It must be well addressed. Okay, you still watching? There are still 2 viewers on the channel. In that rest, that is sufficient. Queen ntabwo bigaragara neza, teacher. Truly. Queen, ntekereze ko noneho ikibazo cyakemutse. Queen Gislaine. Cyakemutse? Gislaine? You can text me using your WhatsApp. You can text me using your WhatsApp. It doesn't matter, Queen. And I thank you very much for letting me know that. Let me give you one more example about finding the matrix representation of f relative to the standard basis. So the question was not finished. Let me write it. Let me write the question and its answer. So the matrix representation of f relative to the basis must be, there must be 2. This is the first column while this is the second column, guys. Here is for 2, the second column must be this. Here is -2, 1. That is the matrix representation of f relative to the basis. But these bases are standard. The bases are standard. If the bases are not standard, matrix of linear transformation relative to any basis. When the basis is not standard, what do we do? Look, we have having f of e1 and f of e2. Both f of e1 and f of e2 must be written as a linear combination of the bases here given. Both f of e1 and f of e2 must be must be written as a linear combination of the bases. And thus, we do not consider f of a1, but rather we consider their coordinate vectors. We consider the coordinate vector of e1 and the coordinate vector of e2. That's it. We do not consider f of e1, but we consider f of e2. So, write matrix representation of f relative to the basis B a11, a12, a21, a22. That's how we are going to do this. So f of e1. Here, f of e1 must be, we have this and this. We have a11 e1 plus a21 e2. Look for a11 and a12. After getting their values, they will be put here. So f of e2 also, f of e2 is going to be, we consider this. We consider this a12 and a22. There is a12, e2, sorry, e1 plus a22, e2. Here it is. Now, even here, you will be finding the value of a12 and the value of a22. After getting them, all values of a's will be put here. That is how we find the matrix representation of f relative to n basis. Nisa Jessica, we are not seeing lab screen. Hope it's there. Jessica, isn't the live screen there? Hope it's back. Okay, yego teacher mwiza ntabwo bigaragara neza teacher koko. Koko Giselene mwiza. Giselene reka tubikemure. I'm here for you, Giselene. Is it clear? Hope it's now looking clear. Uh, we can have an example. Patro ati kombona teacher kombona gushaka f of e1 and f of e2 are kimwe. Yes, they are done in the same way. Let me give you an example. You will be seeing how easy the question is, and the lesson is very simple. It's very simple. Yes, he adds, relative to any basis. Let me show it to you guys. But here, as you see, the coefficients are not the same. The coefficients we need to find are not the same. For E1, we multiply. For f of E1, we multiply E1 here, E2 here, and sum them. For f of E2, we multiply E1 here and E2 here, and sum them up. So this A11, A21, A12, A22 must be found. The aim is only to find those constants. After getting them, it will be easy to write the matrix of linear transformation. Okay, let's have a simple example. Example, consider the transformation, the linear transformation. Defined on R2 by f of xy, which is equal to 4x minus 2y, comma 2x plus y. Determine its matrix relative to the basis. These are E1 here is equal to 1, 1, E2, which is minus 1, 0. We stop here after finding this matrix because here is about an hour and about 2 hours watching, about 2 hours studying. Now, as we said, we need to find f of E1. This is going to be f of our E1 is 1, comma 1. This means x will be replaced by 1 and y will be replaced by 1, as you see here. This is going to be 4 into 1 minus 2 into 1, comma 2 into 1 plus 1. This is, we have 4 times 1, that is 4, minus 2 times 1, that is minus 2. We have 4 minus 2, which is 2, and you have 2 times 1, that is 2, plus 1 is going to be 3. It's going to be 3. So, the next is f of E2. What is f of E2? This is going to be f of minus 1. X is going to be replaced by minus 1, while y is going to be replaced by 0. So instead of having x, we're going to have minus 1. Instead of having y, we're going to have 0. This is 4 into minus 1 minus 2 times 0, comma, we have 2 into minus 1 plus 0. This is going to be minus 4 minus 0, that is minus 4. And here is minus 2 plus 0, that is minus 2. As I told you, we need f of f, matrix representation of f relative to the bases. We need it to be like a11, a12, a21, a22. Okay? Now, we need to write f of e1 as the linear combination of the bases. Here, we consider this. F of e1 will be a11 e1 plus a21 e2. As I told you, we take this column vector. Okay, it is clear that we have a11 times the basis is 1 1 plus a21 times minus 1 0, and this will be f of e1 is 2 3. Here is 2 3. This means a11 minus a21 minus a21 is going to be 2. A11 plus 0 is going to be 3. This means a11 is 3. We can have a21 be given by a11 minus 2. Here, a21 is going to be given by a11 minus 2. A21 will be having the value 3 minus 2, and a21 is going to be 1. Here are the values of a11 and a21. Doing the same, we are going to have this. We saw that f of e2 is equal to a12 e1 plus a22 e2. This means a112 into 1 1 plus a22 into minus 1 0. This will be given by our f of e2 is minus 4 minus 2. This implies a12 times 1 minus a22 is minus 4. A12 plus 0 is going to be minus 2. Here, a12 will be given by minus 2. This means a22 will be given by a12 It will be given by A12 plus 4. Okay? And A22 is going to be A12, that is minus 2 plus 4. A22 here is going to be 2. Okay. The matrix representation of F relative to the basis will be given by our A11. Our A11 is 3. Our A21 is 1. Our A12 was here found as minus 2. A22 is 2. This is the matrix representation of F relative to the basis, guys. And the basis, as you see, the bases are not standard. If they are standard, we could have done that in this way. Thank you very much for your attention, and thank you very much for your help, guys. We are going to end our course here. We'll be meeting next time. Hope that right now there's no question. Let me check your WhatsApp. There is no new message. There is no new message. And I thank you for being with us. Thank you for being with us. Okay. If anyone has question, you can let me know the question. There is a comment section. You can type your question there, and when reading those comments, your question will be truly answered. Before leaving the class, I want you guys share the live. I want you like the live. If you didn't subscribe to the channel, let me remind you to subscribe. May even God be with you. Thank you very much. And I want to say to you goodbye. See you next class.